Using a determinant is another method to calculate a cross product. And as we do this, you'll hopefully note, or I'll note to you, that the formula that we used in the previous video is exactly the same as what's actually happening here. This might be a way to do it where it's more familiar, you know, the process, or hopefully remember the process of how to calculate the determinant of a 3x3 matrix. If you're not familiar, I'm going to isolate the first row. So we're dealing with the first row here. And we take each individual piece. So if I take the I eliminate everything, well, certainly in the first row, and everything below it. And I'm left with those four components there, which are set up here. So the U2, U3, V2, V3 are set up there. Similarly, if I'm dealing with the J, that's the one I want, I eliminate this column and this row, and I'm left with these guys here, which coincidentally form right there. For the middle one, we have to subtract, and after that we add. So let's erase this, and let's give it a shot. Let's try to do this one. Calculate this determinant. Again, essentially what we have here are vectors U is 1, -1, and 7. And V is 2, 0, 3. We're going to calculate the determinant of this, which will give us the cross product U cross V. So U cross V, so -1, 0, 7, and 3 times I. Subtract, looking at J, so it's the 1, 2, it's the first column, and then the third column is 7, 3. That's J. And then we add the third one. So when we get rid of K, we're left with the first column 1, 2, and the second column -1, 0. And now we do the determinant. So recall, if you have this, determinant of this is AD minus CB. That's all right, so we will continue. We get -1 times 3 is -1 times 3 is -3. And we're subtracting 0 times 7, which is 0, and all of that's going to multiply by I. We're subtracting this here, so it's 1 times 3, which is 3, minus 2 times 7, which is 14. And 1 times 0 is 0, minus a -2, which means it's going to be plus 2. We'll fix that in a second. So this gives us -3i. It's a -11 in there, so it's positive 11j. And we have a 2, so plus 2k. And that means that equals -3, 11, and 2 in component form.